For centuries, astronomers have gazed into the cosmos, searching for answers to the greatest mysteries of our universe. But what if everything we thought we knew was just the beginning? Yes. The James Webb Space Telescope, JWST, has shattered our expectations, uncovering cosmic anomalies that defy current theories. It has seen beyond the so-called dark ages of the universe, revealing distant galaxies and black holes that shouldn't exist, at least not according to our understanding of cosmic evolution. Are we witnessing a rewriting of the laws of physics? A glimpse into an ancient universe far older than we ever imagined? Or is something even more extraordinary at play? What JWST found has left scientists stunned, and it might just change everything we know about the cosmos. Will the history of astronomy be divided into before Webb and after Webb? The answer, it seems, is a resounding yes. The James Webb Space Telescope, JWST, has already begun to rewrite the cosmic narrative, revealing discoveries that challenge our understanding of the universe. But with these revelations come more questions than answers. Are we witnessing a mistake in our observations, a flaw in our interpretations? Or is nature surprising us with something entirely new? A new kind of dark matter, a new form of dark energy, or perhaps something even more extraordinary? If there's a Nobel Prize waiting in the cosmos, this might just be where it's hiding. Take a moment to look at this image. What you're seeing is a distant cosmic structure shining brightly in the early universe. This discovery has solved a long-standing mystery in astronomy, but it has also opened a Pandora's box of new enigmas. According to our current understanding, the universe came into existence about 14 billion years ago with the Big Bang. Shortly after, it entered a period of complete darkness known as the Dark Ages. During this time, the universe was filled with dense clouds of gas, obscuring any light. Even with the most powerful telescopes, peering beyond this era seemed impossible. But for decades, astronomers have noticed something strange, faint glimmers of light emanating from these dark clouds. Now, thanks to the James Webb Telescope, we're beginning to understand what these lights are, and the implications are staggering. The dark ages of the universe were a time of profound obscurity. After the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, protons and electrons combined to form neutral hydrogen, filling the cosmos with opaque gas clouds. No stars, no galaxies, no light, just darkness. This period lasted for hundreds of millions of years until the first stars and galaxies began to form, ionizing the hydrogen and ushering in the cosmic dawn. But how and when this transition occurred has remained one of the greatest mysteries in cosmology. Enter the James Webb Telescope. Designed to peer deeper into space and further back in time than any instrument before it, JWST has now observed objects that existed during and even before the cosmic dawn. What it found has left scientists stunned. In December 2022, less than 6 months after commencing science operations, NASA's James Webb Space Telescope revealed something never seen before. Numerous red objects that appear small on the sky, which scientists soon called little red dots, LRDs. Though these dots are quite abundant, researchers are perplexed by their nature, the reason for their unique colors, and what they convey about the early universe. A team of astronomers recently compiled one of the largest samples of LRDs to date, nearly all of which existed during the first 1.5 billion years after the Big Bang. They found that a large fraction of the LRDs in their sample showed signs of containing growing supermassive black holes. We're confounded by this new population of objects that Webb has found. We don't see analogs of them at lower redshifts, which is why we haven't seen them prior to Webb, said Dale Kachevsky of Colby College in Waterville, Maine, and lead author of the study. There's a substantial amount of work being done to try to determine the nature of these little red dots and whether their light is dominated by accreting black holes. A significant contributing factor to the team's large sample size of LRDs was their use of publicly available Webb data. To start, the team searched for these red sources in the Cosmic Evolution Early Release Science (CEERS) survey before widening their scope to other extragalactic legacy fields, including the JWST Advanced Deep Extragalactic Survey (JADES) and the Next Generation Deep Extragalactic Exploratory Public (INGDEEP) survey. The methodology used to identify these objects also differed from previous studies, resulting in the census spanning a wide redshift range. The distribution they discovered is intriguing. LRDs emerge in large numbers around 600 million years after the Big Bang and undergo a rapid decline in quantity around 1.5 billion years after the Big Bang. The team looked toward the red unknowns, Bright Infrared Extragalactic Survey, RUBIES, for spectroscopic data on some of the LRDs in their sample. They found that about 70% of the targets showed evidence for gas rapidly orbiting 2 million miles per hour, 1,000 kilometers per second, a sign of an accretion disk around a supermassive black hole. This suggests that many LRDs are accreting black holes, also known as active galactic nuclei, AGN. The most exciting thing for me is the redshift distributions. These really red high redshift sources basically stop existing at a certain point after the Big Bang, said Stephen Finkelstein, a co-author of the study at the University of Texas at Austin. If they are growing black holes, and we think at least 70% of them are, this hints at an era of obscured black hole growth in the early universe. Contrary to headlines, cosmology isn't broken. When LRDs were first discovered, some suggested that cosmology was broken. If all of the light coming from these objects was from stars, it implied that some galaxies had grown so big, so fast, that theories could not account for them. The team's research supports the argument that much of the light coming from these objects is from accreting black holes and not from stars. Fewer stars means smaller, more lightweight galaxies that can be understood by existing theories. This is how you solve the universe-breaking problem, said Anthony Taylor, a co-author of the study at the University of Texas at Austin. Curiouser and curiouser. There is still a lot up for debate, as LRDs seem to evoke even more questions. For example, it is still an open question as to why LRDs do not appear at lower redshifts. One possible answer is inside-out growth. As star formation within a galaxy expands outward from the nucleus, less gas is being deposited by supernovas near the accreting black hole, and it becomes less obscured. In this case, the black hole sheds its gas cocoon, becomes bluer and less red, and loses its LRD status. Additionally, LRDs are not bright in X-ray light, which contrasts with most black holes at lower redshifts. However, astronomers know that at certain gas densities, X-ray photons can become trapped, reducing the amount of X-ray emission. Therefore, this quality of LRDs could support the theory that these are heavily obscured black holes. The team is taking multiple approaches to understand the nature of LRDs, including examining the mid-infrared properties of their sample and looking broadly for accreting black holes to see how many fit LRD criteria. Obtaining deeper spectroscopy and select follow-up observations will also be beneficial for solving this currently open case about LRDs. There's always two or more potential ways to explain the confounding properties of little red dots, said Koshevsky. It's a continuous exchange between models and observations, finding a balance between what aligns well between the two and what conflicts. These results were presented in a press conference at the 245th meeting of the American Astronomical Society in National Harbor, Maryland, and have been submitted for publication in the Astrophysical Journal. Recently, the James Webb Telescope captured images of two ancient galaxies that existed beyond the Dark Ages. These galaxies are unlike anything we've seen before. They are highly redshifted, meaning they are incredibly distant and existed in the universe's infancy. But here's the catch. Their existence challenges our understanding of galaxy formation and the timeline of the universe. One of these galaxies, named GNZ11, lies approximately 13.2 billion light-years away. Initially spotted by the Hubble telescope, JWST's observations have revealed something even more extraordinary: a supermassive black hole at its center. This black hole, forming just 400 million years after the Big Bang, is far larger than our current models of black hole formation can explain. How did such a massive object form so quickly? The discovery of these galaxies and their supermassive black holes suggests that the early universe was far more dynamic and complex than we ever imagined. But it also raises a troubling question. Are we wrong about the age of the universe? Or is there something fundamentally missing from our understanding of cosmic evolution? The mystery of Lyman alpha emissions. One of the most puzzling aspects of these discoveries is the presence of Lyman alpha emissions. These emissions, a type of ultraviolet light, are typically associated with star formation. However, during the Dark Ages, the dense hydrogen clouds should have absorbed this light, making it invisible to us. Yet, JWST has detected Lyman alpha emissions from these ancient galaxies. How is this possible? Researchers believe that as stars formed in these early galaxies, they created bubbles and channels of ionized hydrogen within the neutral gas. These bubbles allowed the Lyman alpha emissions to escape, providing a glimpse into the universe's earliest epochs. This discovery not only confirms that stars and galaxies existed earlier than we thought, but also suggests that the early universe was far more active than our models predicted. Galaxies beyond the Dark Ages. Perhaps the most shocking revelation from JWST is the existence of galaxies that predate the cosmic dawn. These galaxies, located at a redshift of around 16, existed during the Dark Ages, a time when, according to our current understanding, no galaxies should have formed. This discovery has profound implications. If these galaxies are confirmed through spectroscopic observations, it could mean that our universe is much older than we thought. Alternatively, it might suggest that some unknown process accelerated the formation of galaxies in the early universe. Rewriting cosmology, the conformal cyclic model. As scientists grapple with these findings, new theories are emerging to explain the anomalies. One such theory is conformal cyclic cosmology, proposed by Nobel laureate Dr. Roger Penrose. According to this model, our universe is just one in a series of cyclical universes, or eons. At the end of each eon, black holes evaporate, releasing energy that triggers the Big Bang of the next eon. Penrose suggests that remnants from a previous eon, such as dead black holes, could have influenced the formation of supermassive black holes and galaxies in our universe. This theory could explain the existence of massive black holes and galaxies in the early universe, as observed by JWST. A universe of infinite possibilities. The discoveries made by the James Webb Telescope are nothing short of revolutionary. In just its first few years of operation, JWST has shattered cosmic records, revealing the most distant galaxies, black holes, and quasars ever observed. These findings suggest that our universe might be far older and more complex than we ever imagined. But the implications go even further. If the universe is infinite in size, could it also be infinite in age? Could the Big Bang be just one moment in an endless cycle of cosmic evolution? These are the questions that JWST is forcing us to confront. What does this mean for the future of astronomy? The James Webb Telescope has already changed the way we see the universe. Its discoveries are challenging our most fundamental assumptions about cosmic history, galaxy formation, and the nature of dark matter and dark energy. As we continue to analyze the data, one thing is clear. We are standing on the brink of a new era in astronomy. So what do you think about these discoveries? Do they change your understanding of the universe? Could the universe be older than we thought? Or is there something even more profound at play? Share your thoughts in the comments below, and let's explore the cosmos together. This is just the beginning. With every new observation, the James Webb Telescope is peeling back the layers of the universe, revealing secrets that have been hidden for billions of years. And as we gaze into the depths of space, we are reminded that the universe is far stranger and more wonderful than we ever imagined.